Very good morning to everyone. We were dealing with the various types of impurities that can be present in the pharmaceutical substances, starting from active pharmaceutical ingredients and to the formulations. As we know, various impurities gets introduced into the pharmaceutical formulations from the starting materials to the intermediates formed during the process of the manufacturing and during the storage of the manufactured products. The question is how to control these impurities we have seen. Now, whether those impurities are in controlled limits, how to identify that? As we know that in sodium hydroxide, Indian Pharmacopoeia prescribes the limit of 3% for sodium carbonate. If I take 100 grams of sodium hydroxide, it can get it can have 3 grams of sodium carbonate as impurity. That is the permissible limit that has been given by prescribed by Indian Pharmacopoeia. Now, to know whether it is within 3% impurity or is it more, whether it is within the limit, to know that we design test for purity. Pharmacopoeia prescribes test for purity. How much it what is the what it indicates is that how much pure it is. We do the test to know the purity of the pharmaceutical substance. Pharmacopoeia, by this test for purity, it fixes the limit of tolerance for these impurities. For certain common impurities, the pharmacopoeia prescribes the test for purity. This includes color, taste, and odor of the substance. It also prescribes the physico-chemical constants like iodine value, saponification value, melting point if it is a solid, boiling point if it is a liquid, refractive index, and so on and so forth. The acidity, alkalinity, or it indicates the pH of the substance. And it indicates the test for purity for a amount of moisture or humidity that can be present in the particular ingredient. The cations and anions, ash, arsenic limit or lead limit, and it also prescribes the Lawson drying and Lawson ignitions. How these are tested? That is the subject of discussion for today's class. There are various quantitative and semi-quantitative tests designed to identify the impurities present in the active pharmaceutical ingredient and also to know the quantity of impurities that is present in the pharmaceutical ingredients and to also to know whether these impurities are under control. As the name indicates, quantitative or semi-quantitative tests are designed. Quantitative, as the name indicates, It shows or tests the quantity of impurity that is present in the that may be present in the particular raw material or the particular product. Semi quantitative test means it do not indicate the exact amount of impurity present, but it detects the impurities that are present. These semi-quantitative and quantitative tests are designed fall under the three types of tests. First type of tests are those tests in which there is no visible reaction. What we are going to do, the impurities present in the molecule, we are making it to react with certain substances or reagents or reactants what we add, and it should produce some indication in the form of a color or in the form of a precipitate. And the amount of precipitate that is formed and the amount of color, intensity of color that is formed, it indicates how much amount of impurity is present. And there are certain tests in which there are no visible reactions. When there is no visible reactions, how to test, how to compare? We are using sophisticated instruments. Right. There are next set of or type of tests which are designed. They are quantitative determination or quantitative tests. These are the tests which are designed to determine the quantity or amount of impurity that may be present in a particular ingredient or the product. Here exactly it gives the amount of quantity present, impurity quantity that is present. Or it also indicates the percentage purity of the major ingredient. Another set are semi-quantitative tests or semi-quantitative determination. It do not indicate the amount or quantity of impurities that may be present in the product, but it indicates whether the impurity is present or not, and also it indicates whether it is in the limit of permissibility or not. This semi-quantitative determinations are called as limit tests. In the limit test, we use a standard solution and we make the reaction to occur, which can produce a particular type of precipitate, or it gives the coloration, and the amount of precipitate that is formed or the intensity of the color that it is given indicates the amount of the impurity that can be present in the pharmaceutical product. That's why we are comparing with the standard solution. That's why they are also called as comparison methods. The limit tests are generally designed to indicate the inorganic impurities that may be possibly present in the pharmaceutical product or within the limits or not, as per the prescription of the pharmacopoeia. To design these limit tests, various factors are considered. This includes specificity of the test, sensitivity of the test, and selectivity of the test. Specificity, what it indicates, as the name indicates, specifically the reaction should occur selectively towards a specific impurity. Like I have sulfates as impurities, ions, or halogen ions as impurities, the reagent what we add should react specifically with either halogens or with sulfates. It should not react with both sulfates and halogen. And when it is specifically reacting with certain types of impurity, it gives the coloration or the precipitate, and that indicates only that reaction. Others, it won't react with it. For example, if I take the product what we have prepared has been contaminated with heavy metals like lead. In this, we are using thioacetamide as a reagent. The alum is the raw material which we use. Thioacetamide reacts with the heavy metals present in the alum to give a precipitate at pH 2.5. In this test, the thioacetamide reacts with all the heavy metals that are present in alum and it gives the precipitation. This type of tests are not very specific. If it specifically react with a particular heavy metal, then its specificity is higher. These are less specific in nature. What the sensitivity indicates? Sensitivity indicates if it is present in microgram quantities, then it produces a coloration or precipitate. If it is present in picogram quantities, it is very less. Then the reaction is less and it may not give the visible results. And it cannot give the reproducible results. What is reproducibility? Whether I do or you do or others does. It should give the same results. Whether I do at Andhra Pradesh or Maharashtra or Karnataka, within India or outside India, it should give the same results. That indicates the sensitivity of the reaction. The precipitate which is formed are the insoluble substances. That precipitation formation depends upon various factors like concentration of the starting material we use, concentration of the reactant we use, the concentration of the precipitating we use, duration of the reaction, temperature of the reaction, pH of the reaction, all affects the sensitivity of the reaction. That's why all these factors to be standardized when we design these limit tests. Usually, cold dilute solution gives light precipitate, whereas hot concentrated solution gives granular precipitate. The selectivity of the test is another factor which we consider while designing these limit tests. The selectivity, to give an example, it is an ability of the test to detect and differentiate very small amount of impurities of similar nature, whether it is in the permissible limits or not. I take chlorides, bromides, iodides, fluorides. All are halogens. And they all are in ionic form. If I add a reactant, it should react specifically with either selectively with chlorides or bromides or fluorides or iodides. Selectively, if it reacts with chlorides, it gives the limit test for chlorides. If it reacts with all halide ions, then it is not selective in nature. How much selective it is in the test is how much specific the reaction is and how much sensitive the reaction is. Based on this, we are designing the limit tests. Why these limit tests are of very much important for active pharmaceutical ingredients, as it detects the harmful impurities and the amount of harmful impurities that may be present in the pharmaceutical ingredients, or it also detects whether these harmful impurities that is present are within the permissible limits or not. For limit tests, we use a specific apparatus called as Nessler cylinder. This Nessler cylinder is a special apparatus designed to carry out the limit tests. What are these Nessler cylinders? They are nothing but the tubes made up of glass, which is clear and colorless. And these clear colorless glass tubes are used to compare the amount of precipitate or the amount of colors, the coloration that is formed during the reaction when we add some reactants. By these reactants reacting with the impurities present in the product. That's why we are matching. One is used for standard solution, another is used for test solution. That's why they are called as match tubes. These tubes are uniform in diameter and it has a flat transparent base. The capacity of this Nessler cylinder is 50 ml. The height of the Nessler cylinder or the length of the Nessler cylinder is 150 millimeter and it has a capacity of 50 ml and it is marked, it has two marks, one at 25 ml, another at 50 ml. The distance from the 50 ml mark and the tip of this Nessler cylinder difference is around 40 millimeter. The difference between 150, the length of the tube is 150 millimeter. The marking of 50 ml is at 110 millimeter. There has a 40 millimeter gap. It typically looks like this. It has a 50 ml, 25 ml or 50 ml, or general it can also have 100 millimeter or 100 ml capacity. These are the Nessler cylinder which we use for the limit tests. How the limit tests for various inorganic impurities are performed, how these Nessler cylinders are utilized will be subject of discussion for the coming presentation. Till then, have a nice day.